What's good, Logan? All right, so what we're going to do now is we're going to try to write the equations of some polynomials, polynomial functions. Here's the thing. All of these have infinite answers. We'll get into more detailed problems where there's only one solution, but these ones we're going to have multiple answers. So the first thing we're going to do is we're going to understand that these are the solutions we have. So we have three solutions. What this indicates is we're going to have a third degree polynomial. Now, the way that this is going to occur is because we're going to have three factors. Our first factor is going to be from this guy right here. So we're going to have x plus 5. So we're going to have x plus 5 as our first factor. And then the second factor is going to be from that guy right there. So x minus 3. And then finally, our last factor is going to be x minus 8. Now remember, what's happening here is we're trying to write the equation where the solutions are going to come out. And if we had to solve it at this point, we would go, oh yeah, x plus 5 is equal to 0. And then that means x equals negative 5. That's exactly what's going on, is that we're writing the equation that's going to have all of these solutions right there, just like that. So now what we're going to do is we've got the factors set up. So now all we have to do is just write the polynomial. That means we're going to multiply this stuff out. So we're going to go through and FOIL it now. So we're going to go x squared plus 2x minus 15. So I'm doing a lot of the math in my head for this one right here because I've got 4 examples I'd like to show you guys for tonight. And then now we're going to have to distribute this one. This one's going to take a little bit more time. So x to the power of 3 minus 8x to the power of 2 plus 2x to the power of 2 minus 16x minus 15x plus, what is that going to be? Is that 120? 120? That's kind of big. All right, so we got that right there. Is equal to 0, is equal to 0. Now we have to simplify it, so we're going to go ahead and collect like terms. So we have x to the power of 3 minus 6x squared, minus 6x to the power of 2 minus 31x plus 120 is equal to 0. And that right there is one of the polynomials. It's a polynomial of least degree that is going to have the answers or the solutions of negative 5, 3, and 8. Now, if we were talking about having x-intercepts for the function, then we would write the function out as x to the power of 3, f of x is equal to x to the power of 3 minus 6x squared minus 31x plus 120. Just pay attention to what it's asking for. Is it asking for this equation where the solutions are as follows? That's going to be the equation right there. Or is it asking for the function that has those zeros or those roots or those x-intercepts? All right, now we're going to get into some more complicated type of questions here. What if we had 6 and square root of 3? Now, what the irrational conjugate theorem states is that if you have an irrational root or an irrational factor or an irrational zero, then its conjugate must be there. The conjugate is just going to be the square root part with the opposite sign. So we're going to have the square root of negative 3. And now we're just going to write down the factors of that. So we're going to go x minus 6, and then we're going to go x minus the square root of 3, just for the, so that we're clear, that's that guy right there, that's that one. And then we're going to have x plus the square root of 3. If you haven't noticed it yet, all we're doing is writing the opposite with the x. And then now we're going to multiply this out. Now, I could multiply these two. It's not the best strategy. I really should be multiplying those together because they're conjugates. And conjugates, kind of like a plus b and a minus b, have a pattern when you multiply. And that pattern, we've seen several times, is going to be a to the power of 2 times b to the power of 2. Cuts out the middle part of the multiplication or the FOIL. So we're just going to take the a, we're going to square it, minus the b, which is square root of 3, and we're going to square it as well. And that's going to give us x squared minus 3 times the x minus 6 at the very beginning of the problem. So having that factoring pattern right there, or the multiplication pattern, makes things just go so much smoother. And then we multiply this out, and we're going to get x to the power of 3 minus 6x squared minus 3x plus 18. And this is our polynomial equation. All right, let's try this again, except this time, rather than having just the radical, we have an irrational number that has a rational part and an irrational part to it. So we want the conjugate. Now remember, the conjugate is not negative 4, but it's actually going to be positive 4 minus the square root of 2. So it's just changed the sign on the square root part of it. This is where it's going to get a little bit more complex. So we're going to go x plus 1, that's the first factor. And the next factor, oh my gosh, be careful, x minus the 4 plus the radical 2. Kind of crazy, but it's the opposite of the entire factor right there. The opposite of the entire root or x-intercept. And then we're going to do the same thing here, x minus 4 minus the square root of 2. All right, now you can multiply these out however you want. I'm going to restructure the problem just a little bit. So we have x minus 4. I actually don't want to put the parentheses in there, minus the square root of 2. That's going to be the first one right there. And then we're going to have x minus 4 plus the square root of 2. Now, we can kind of finagle this a little bit. What I'm going to do is I'm going to focus on this guy right here and this guy right here. And I'm going to focus on that one there and that one there. And if you don't see it, we now have something that kind of looks like A minus B and A plus B. One more time, we have something that kind of looks like A times A minus B, times A plus B. And once again, we have something in that format of A squared plus B squared. So that's what I'm going to do is I'm just going to multiply this thing out going x minus 4 squared. That's the A minus the square root of 2 squared. So we're going to multiply that guy out right there. And that's going to give us x squared minus 8x. Once again, using that pattern multiplication or that pattern of FOIL minus 2. Simplify that. That's going to be x squared minus 8x plus 14. And not to forget that original factor of x plus 1. Let's multiply that guy through also. And that's going to give us x to the power of 3 minus 8x squared plus 14x plus 1x squared minus 8x plus 14. And then we're going to go ahead and make this look even cleaner by combining all the like terms. Minus 7x squared plus 6x plus 14. And ta-da! We have our equation of least degree for that polynomial. All right, moving on to number 4. Now, number 4 is kind of a trip because now this one's going to use the complex conjugate theorem, and this one has 0 real roots. 0 real roots. So we're going to have to find out all the roots here. There are a total of 4 because this guy has its conjugate, which is negative 5i, and then the 3 minus i also has his conjugate, 3 plus i. And now I have to write all the factors for all of those conjugates. So I'll start with the red ones first. I'll color code it. So we're going to go x minus 5i, that's for the top one for that guy right there, times x plus 5i. Remember, it's the opposite, so that's why we're going to go plus on that one. And now we're going to do the blue ones. The blue ones get a little kind of weird. We're going to go x minus 3 minus I. That's this guy right here. So x minus that times x minus, we're going to do this one, x opposite of 3 plus I. Now we're going to have to multiply these things out over here. Good news is this is in a squared minus b squared format. So we're going to go x squared minus 5i squared. And that's going to come out to x squared plus 25. So the red one's going to multiply out to x squared plus 25. And then the blue one, we're going to go, actually, let's not skip a line there. We're going to go x minus 3 plus I. So we're just distributing the negative, and then x minus 3 minus I. Once again, we've got that whole a times a and b times b. So we can just go x minus 3 squared. Once again, using that pattern of multiplication, minus I squared. X minus 3 squared comes out to x squared minus 6x plus 9, and then plus 1 from the negative I squared. And that's going to be x squared minus 6x plus 10. And we're going to have to multiply that blue polynomial with that red polynomial of x squared plus 25. All right, so we multiply this thing out here. I'll just throw the answer over there. We're going to go x to the power of 4 minus 6x to the power of 3 plus 10x squared plus 25x squared minus 150x plus 250. And we're going to go and collect like terms on that guy, x to the power 4. There's only 2 like terms here. That's going to be the plus 35x squared minus 150x plus 250 is equal to 0. All right, that's going to call it a night there. If you guys have any questions, please hit me up. If you saw any mistakes, let me know. I didn't do I didn't run through it once to see if I, make sure I got the answers right. So there might be some mistakes in there. Hit me up. Let me know if there is. If you have any questions, hit me up on the email. Other than that, I'll see you guys in class tomorrow. Peace.